This is an explanation of special segments in triangles. First one is a median. A median is a segment that goes from a vertex to a midpoint of an opposite side. So there are three of them because there are three vertices. No matter how I move this thing around, it's always from a vertex to a midpoint of an opposite side. These are rounded off values. An altitude goes from a vertex to an opposite side and makes a right angle. Now, that's easy to see for acute triangles. Now, for a right triangle, an altitude is a leg of the triangle. For an obtuse triangle, to go to the opposite side and make a right angle, you have to actually extend that third side and go down to it that way. An angle bisector is going to divide an angle into two congruent angles. And we can look at that as a segment, or we can extend it to an array if we want on a line. And there's three of those. There's three of all these because there's 3 points and 3 sides. And the perpendicular bisector doesn't have to go to a vertex, only one. It goes through a midpoint and is perpendicular to that side. So it's perpendicular to this side and it's going through the middle of it. So I can move this around. Again, these are rounded off values. That doesn't change anything. It's always going to be perpendicular. Now, other properties. If you construct the three medians, these are the three medians. They all go through one point. They're concurrent at one point called the centroid. Centroid is the center of mass, and it also splits each median into two pieces, the longer piece and the shorter piece. The longer piece is always twice as big as the shorter piece. You could say the shorter piece is half the length of the longer piece, no matter how you move these things around. And the centroid is always inside the triangle. Circumcenter. The circumcenter is where the perpendicular bisectors intersect. The acute triangle is on the inside, right triangle is on the hypotenuse, obtuse it's outside the triangle. It is the center of a circumscribed circle. The incenter is the concurrency point of the angle bisectors, and for acute, for right, for obtuse, that's always inside, and that's the center of an inscribed circle in a triangle. And then we've got the orthocenter. The orthocenter is where the altitudes intersect. And again, it's a point of concurrency. They all intersect at the same spot. And for acute, it's inside. For a right triangle, it's on the vertex of the right angle. For an obtuse, it's outside the triangle. And one more little add-on is there's something called the Euler line. Every triangle has an Euler line. It turns out that the orthocenter, the centroid, and the circumcenter are concurrent. They're on this thing called the Euler line. So the incenter is not, but these three are. Other properties of the perpendicular bisector. If the blue line here is a perpendicular bisector of this side of the black triangle, so we've got our black triangle. Now, the thing about the perpendicular bisector is any point on there, say the red point, is equidistant from the two endpoints. So this point is equidistant from these 2 points, which are the endpoints of the perpendicular bisector. Pick another point, like the green point, is equidistant from these 2 points, which are endpoints of the perpendicular bisector. Angle bisector works in a similar fashion. Here we've got our triangle in black, and in blue is our angle bisector. Any point on the angle bisector is equidistant from the 2 sides of the angle that you're bisecting. So this point is the same distance from these 2 sides. This red point is the same distance from these 2 sides. Here's a summary of some of this information. So you've got your perpendicular bisector, definition and center. It bisects a segment that's perpendicular to it, and the center is called the circumcenter. For the angle bisector, it bisects an angle, and the center is called the incenter, the point of concurrency. A median, the vertex goes from a vertex to an opposite midpoint, and concurrent in the centroid. Altitude, vertex to an opposite side, it's perpendicular to that side, it's orthocenter. The property of the center, it's the center of a circumscribed circle. Center of an inscribed circle for incenter. The median, it's called the centroid, it's the center of mass, and it splits into a ratio of 2 to 1 each median. This is where those centers lie for acute, right, and obtuse triangles. And finally, this is whether they're on the Euler line or not. A few examples is how is WY related to XZ? WY and XZ, well, WY is the perpendicular bisector of XZ because you can see it's perpendicular and it's bisecting it. XV is going to be the same as VZ before. WZ will be the same as WX. We know those will be the same length because W is on the perpendicular bisector. Skipping down to here, we want to find X and step is equal to each other. We know they're going to be the same because they go from point R, which is on the perpendicular bisector of HJ, so these must be the same distance.